In this video, I'm going to be walking through the Module 4 project. Here's the template pulled up on the screen now. Please use the template to submit all your answers. So I'll walk through this template, what I'm looking for, and also explain a lot of the procedures in Excel. So the first thing on the template, obviously put your name in there, but down here in introduction, describe the report. So let's go back to the overview. In the Project 1 guidelines and rubrics, it sets up the scenario for this project that we're working on. So you're hired by a company and the CEO is asking for a report. And so you're going to work on that report. And here is the whole point of it: to determine the use of square footage of a home as a benchmark for finding out a good listing price of the home. So the company you work for, it's a real estate company. The CEO wants to know how we can use square footage to make good predictions on the price we should list the homes for. All right, and then again, right here, your task is to provide a report predicting the median housing price based on the square footage of the home. So that's your purpose. Your approach is going to be to get a sample of data, and we're going to look at linear regression to see how we can achieve our purpose here. The next part on the template to fill in here under data collection, get a sample, explain how you obtained it and made sure it was random, and then identify your response and predictor variables, and then also put a scatter plot here. Now, if you look back at the directions, our sample should be 50 counties. So this is different than the project or assignments 1 and 2 where you just had a sample of size 30. You need to get a random sample of size 50. So come down here and open the data, real estate county data. And the best way to get a random sample in Excel is to use the equals rand function. You get that random number between 0 and 1. And I'm just using this first region here, East, North, Central. Pick any region you want. I'm going to drag that function down so I don't have to type it over and over. Excel will fill it in all the way through the East, North, Central. Looks like I went a little bit further. That's okay, because I'm just going to select East, North, Central and on up. I'm going to select all that data right there. And then I'm going to sort it, and I'm going to sort by largest to smallest based on these random numbers here. So I go up to data, and I'm going to sort it. And I'm going to sort by column G, which is where my random numbers are, and smallest to largest. And when I click OK, Excel changes all the random numbers every time you do a function, so don't worry about that. But based on what they were, those rows with the 50 smallest numbers are now listed first. So I need to grab the first 50 rows here. I'm just going to go down, and I can use this count here to make sure I got 50. So I want to go from 55 on up, just making sure I get the right size sample. So what I'm actually going to do is copy that into a brand new, I click the plus there, so I get a brand new sheet that now just has my 50 rows of data. I'm actually going to move it. I hit cut and moved it down because I would actually like to get those labels as well, just to I make sure I don't forget what each column stands for. Now I'm going to delete, right click, delete, that's the entire column. I don't need these random numbers anymore. And I also don't need this median price per square foot. I'm trying to look just how the square feet of a house, how can I use that to predict the listing price? So I don't need this column. So delete that column. There we go. Now referring back to our directions here, we're identifying the response and the predictor variable. Your task is to predict the housing price based on the square footage. So square footage is being used to predict the price of the home. If you recall from 2.2 in Zybooks, when we first learned about regression here, the response variable is the variable being predicted. So you're predicting the price of the home. That is your response variable, while the predictor variable is the variable being used to predict that response. So that square footage is your predictor variable. So include your table of data here, your sample of 50. Explain how you know it's a random sample, the process you use to get that. If you do something different than the equals rand function, just explain what you did to make sure it was random. And then write out what the response variable and the predictor variable will be. Also include a scatter plot here from your Excel. To do the scatter plot, it is easier to have the X variable, your predictor variable, listed first. So I'm hitting cut and paste. So my X, my predictor, is first, my response is second. So if I grab those two columns of data and I go insert scatter plot, Excel puts that first column on the X-axis. So your predictor variable, your X, is correctly showing up as the square footage and the home price is the Y. Now make sure you change your title to make it more appropriate for your report here, but you'll want to include the scatter plot in that first data collection spot here. Put your scatter plot. Now let's move on to data analysis. And part of what you want to do here is explain the difference between a response and a predictor variable, say why we're using square footage as our predictor variable, and the home price then is our response variable. So explain that, and then you need to discuss the requirements to use linear regression with a data set. And 3.2 discusses this. We don't need to go into great deal here. You're not going to put a lot of detail about this in your report, but you do want to talk on definitely this first part. The relationship is actually linear. When you look at the scatter plot, the points should be lying on what looks like a linear path. You can mention the correlation coefficient here. It would be great. The closer it can get to 1, it means the stronger that linear relationship is. And you can also briefly talk about the residual plot should not have any discernible pattern to it. You don't need to include a residual plot in your report, but just mention it shouldn't have a pattern like a U shape, or this one again is kind of a U shaped up and down. It should just be spread out equally from the beginning of your data to the end, just no discernible pattern at all in the residual. This one's bad here because it's thinner here and then they're spread out a lot more at the end. So you can mention that quickly. You do not need to include a residual, but it should not have a pattern. Your points should lie along a line, and the correlation coefficient, we would like it to be close to 1 if we're using linear regression. Next, you want to insert a histogram for both of our variables here, one for square footage and one for the price of the home. Refer back to my video for the project or assignment 1 if you have any questions about creating histograms in Excel. I go into the details about it in my video over assignment 1, and there's also at the bottom of the directions here another video. Actually, this might just be it. Screenshots and written out instructions for how to create histograms as well. So you can use that too if you're having any trouble with the histograms. I want to see a table with the summary statistics, and if you look back at the directions, we're looking for mean, median, and standard deviation. So you can go to your data analysis. If you don't have that installed, again, look at my video for assignment 1, or there is help for that again at the bottom of the directions. Descriptive statistics, and this is one way to do it. Your input range. So first you want to do it for one column and then the other. I'll do it for square footage. I'm just going to select it there. I want my summary statistics. Now the output range, I like to just click where I want it. I'm going to make sure my cursor's there and click where I want it. It's going to show up there. I hit OK, and I get the mean, the median, and standard deviation. Those are the main things. Actually, this is standard deviation. Those are the 3 that I want to see. Now, another way to do this, you can go equals average. You can just do each formula one at a time if you don't have that data analysis, or if you just like this method better. So E2 through E51, there's my mean. You see I'm going to get the, if I go home and if I add some more decimals here, you see I get the same thing as the mean. I can go equals median, and I forgot what E2 through E51. That's what I want. Equals median gives me the same median value. and then standard deviation of a sample. So STDEV of my sample from E2 through E51. So E51. And if you type it in like I just did there, you should see it all highlighted if you type it in correctly. And once again, I'm going to get the same answer that I'm getting from descriptive statistics. So two ways to go about getting those: either use the formulas one at a time or use descriptive statistics. And now finally interpret the graphs, so those two histograms as well as the scatter plot and the statistics. So just give a brief overview of them. Do they look skewed one direction? Are they bell-shaped? Are they symmetric? Are there big outliers somewhere or gaps in the data? And so on. Also compare these to the national market. So after creating all your graphs and data, come back here, the national statistics and graphs. You can look at those as well and then compare what you got compared to the national market. How does it compare? How does it contrast? So now coming down, we want to put the scatter plot into our report again, but this time with a line of best fit. So coming back to Excel, you can reuse that same scatter plot, but just right click on any of the points here and add the trend line. It's going to add the line of best fit in there for you. And you want to display the equation and the R-squared value as well. I'm going to click X here and move those somewhere where I can see them a little better. Do some rearranging here. You can actually come up here and increase the size, make it a little easier to see as well. So there you have your line of best fit. You want to include that. And include that here with your scatter plot. Put that and then talk about whether you think the predictions made using this linear regression equation will be useful to the CEO or not. Now he's paying you to do this research, calculate the equation. We're going to go ahead and go through with the remaining parts of this assignment to show him the work we've done, but you do want to let your boss know whether you have some doubts about your equation. Maybe your points didn't look like they followed a linear pattern. Maybe they had some other shape, or maybe there's some extreme outliers, or maybe your R is really, really close to zero. This is R squared. You want to find your correlation coefficient. R is going to be the square root of whatever R squared is. So my square root of 0.6451. My R value is 0.8, which is pretty decent linear correlation. Back in 3.3, if R is anywhere between 0.8 and 1, 1's as high as it can get, we say that's pretty strong correlation between the two variables. So for my scatter plot, it appears that there is, in my region with my sample of data, it appears there is a strong correlation between the square foot of a home and then the price that it should be listed at. But you're going to be working with a different sample, so you might have completely different results. I have seen on some of these projects, instead of a positive regression line, it's actually sloped downward, it's negative. And that kind of doesn't make sense. As the square footage of a house increases, the price should go down, but it's because a linear fit is not great for that sample of data. And you want to let the boss know that this negative linear regression line, I don't recommend using it, because it doesn't make sense that as the square footage is increasing, we're going to drop the home price. So use your sample, your data, your graphs to explain why you think the regression model, this equation here, is going to be good for making predictions about why the home price based off the square footage X, or why you think it would be a bad model to predict home prices based off square footage X. So I've kind of talked through these two parts already. Use that R squared, take the square root of it to find R, and just talk about whether it indicates weak, moderate, or strong correlation between the square foot of a home and the price. And here, I'm just looking for whether it's your scatter plot is going up in the positive direction, or if it's going downward, negative. That's what I mean by the direction, positive or negative. That correlation is whether it's weak, moderate, or strong. So that kind of ties into here with R. And then is it linear or does it seem to have some other shape besides linear? And now this line of best fit part, go ahead and copy out what your regression equation is. It's not bad to type it out here in words. So your Y, your listing price, is equal to, and I'm just copying this from what I got in Excel, 211.58 times X. So multiply that value by the square footage of the home, and then subtract 188.36. So this is my regression equation, and I just replaced the variables with what they stand for to make it clear to the CEO reading this report. We're going to calculate listing price this way. We're going to take the square footage, we're going to multiply it by a value and subtract this, and that's what my regression equation says would be a good value for the listing price. For interpreting the slope and the intercept in the context of our problem, the slopes for any line you ever have, the slope is always as x increases by 1, this is how much y increases by. So our x is square footage. So our slope says as the square footage increases, the house increases by 1 square foot, the listing price of the home goes up by $211.58. Every additional square foot adds that much value to the price of the home. The y-intercept is the value at the end of your equation when x is 0, which in this context means when the square footage is 0, which means there's no house whatsoever. It's saying that the price of the home should be this. So just the land value, there's no house, this should be the price of the home. As you can see, this doesn't make sense. You would never have a negative value for your land. So I would say that in this context, there's absolutely no meaning at all from my y-intercept. And that's often the case whenever our data, our x values are really far away from 0, then the equation we get for our regression equation, often then the y-intercept has no meaning whatsoever if the x values, if there's none of them close to 0. Now your sample might be different. You might have, smaller homes, x values closer to 0. You may get a positive value here, and then you would interpret that as the land value. If there was no home, this would be the price of the land. The strength of our equation, looking at r squared, and you can read more about r squared in 3.3. Basically, we want values closer to 1. That means the regression equation will be even more useful the closer it gets to 1. R squared gives the ratio of the variance in the response variable. So our response variable is home prices, so the fluctuation here in home price, how much of that is explained by square footage of the home? Because with selling homes, there's a lot of factors that go into it. The location, how old the house is, the neighborhood, a whole bunch of stuff. We want to know how much of an effect basically does square footage have on the final price of that home. And so the closer we get to 1 with our r squared coefficient of determination, it's just saying the stronger the role is of square footage in determining that final price. And remember, your r squared will show up right there on your graph. When you right click, add the trend line, you can come down here and display r squared on the chart. And finally, use the regression equation to make a prediction. You're presenting this to the CEO, so you're kind of showing him at the end how all of this will work, how your regression equation will work. And so pick a value for the square footage of a home. You want to make sure it's within the range of your data. So for my sample data with my regression equation, I would want to pick a square footage value, somewhere around 1,500 to 3,000. I wouldn't want something much smaller or much bigger. Stay within the range of your data. But just pick a random x value, square footage value, plug it in there, and then do the calculation. Take the value you pick, multiply it by the slope, and subtract the y-intercept, and then see what the calculation shows that the listing price would be. And then the final part then is just your conclusions. So this is a report you're giving to your CEO. If you were trying to summarize everything that you found into just a paragraph, how would you summarize all of this information? What are the key concepts that you would take away from this? And also, I'm really interested in any follow-up questions that you think would be beneficial for your company to look into, based off of what you found. And what would be maybe the next thing you guys would want to research and look into as you're trying to figure out, the best way to list homes and get the correct price for them. So let me know if you have questions about any parts of this assignment, any of the Excel work, what I'm looking for here in the template. I'll be happy to help as best I can.